In this video, we're going to take a look at conducting a hypothesis test regarding a population mean, but here we're going to look at the p-value method. And we're going to look at the p-value by estimating it from the t-table. There's another video that will tell you how to get the exact value of the p-value using StatCrunch. So take a minute to read over this exercise. Press pause if you need. In this exercise, we have bags of oranges labeled as 10 pounds and a consumer group that suspects that the bags that are being sold are underweight. So our null hypothesis is that the mean weight is 10 pounds. Right? We can't take this on a bag-by-bag basis. We have to look at the average value of the weights, and so we're using mean here. And if they think the bags are being undersold, then on average we would expect to see the bags on average less than 10 pounds, and so this is what's really in question. We have to check the conditions for tests about the population mean. Since we have a sample size that's not greater than 30, luckily we're told that we have a normal distribution of weights, and so we can go ahead and we can use what's called a t-test, which means we're using a t-distribution. This is especially important since the only standard deviation measurement we have is from the sample. So one of the most important things to calculate for any test about a parameter is what's called the test statistic. The test statistic is going to measure how far away our sample statistic is from the claimed value of the proportion. So in this case it's a t-score, sample mean, minus the claimed value of the mean in the null hypothesis, divided by the sample standard deviation over the square of the sample size. So here our sample mean, if you look at the random sample of 10 bags, they had a mean weight of 9.8 pounds, so we do 9.8 minus 10, divided by the standard deviation of 0.33 pounds over the square root of the sample size, square root of 10. So if you calculate that test statistic carefully, you get negative 1.917, which means that the sample mean of 9.8 was almost 2 standard deviations below the value we would expect the mean to be if the null hypothesis were true. And so how unusual is this? Is it unusual to be almost 2 standard deviations below the mean? It's not incredibly typical, but it does happen. So is it more likely that this happened by chance, or is it more likely that this value of 9.8 and 2 standard deviations below is telling us that perhaps really the mean is not 10? And so here we're going to use the p-value approach, which is a little bit different than the last video using the same exercise where we use the classic approach. So the p-value is a measure of the probability that your statistic is further away, or that really any statistic, if we did another sample, that any statistic would be further from the parameter in question. And so since this is a left-tailed test, further means further to the left. So if we think about a t-distribution, because the sample means are going to follow the t distribution here, that would be centered at 0. We got a t-score of negative 1.97, or negative 1.917. So further away from that would be any t-score less than negative 1.97. That would mean the sample mean is less than 9.8. And so this area here shaded in blue represents the p-value. Now our normal distribution table allows us to find these a little bit more precisely. The t-table doesn't work as nicely. So our t-distribution has degrees of freedom 9 here, 1 less than the sample size. And so if we look along the line for 9 degrees of freedom, these are all t-scores here. And so we're looking for a t-score close to negative 1.97, but of course these are all positive. So we want to look for positive 1.917, and we notice that it falls in between these two numbers right here, which means that the area to the right of that is somewhere between those two numbers there, and so by symmetry for negative 1.97, our p-value is then somewhere between 0.05 and 0.025. Now, of course, the general decision rule here is that you only reject the null hypothesis if the p-value is less than alpha. So our p-value is between 0.025 and 0.05, and the significance level is 1% or 0.01. So if we're looking at a number line here, and we've got put those in order, we've got 0.01, we've got 0.025, and then 0.05. Our p-value is somewhere in here, and this is our alpha level. So our p-value is not less than alpha, so we do not reject the null hypothesis. There is not